Okay, moving on to 5.2, which is now perpendicular bisector. So if I split up these two words, perpendicular means hits at a 90-degree angle. Bisector means it cuts it in half. So this piece would equal this piece, right? So a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So if I have a segment, and if I have a segment that hits it at a 90-degree angle, this piece equals this piece. That's a perpendicular bisector. Equidistant means a point that's the same distance. So like this point is equidistant to here and here because maybe they're both 5. Okay. Okay, theorem 5.2 is a perpendicular bisector theorem. What this guy is stating is, I have a perpendicular bisector. I know it's a perpendicular bisector because this is 90 degrees and this piece equals this. It is saying that if I put a point on this perpendicular bisector, so for instance point C, it is going to be equidistant to the endpoints of this segment. So A to C is going to be equal to C to B. And if you notice, what you have created there are two right congruent triangles by hypotenuse leg. The hypotenuse and a leg is congruent, and it's a 90-degree triangle. So we have two congruent triangles. The converse of this is just flip it around. If there is a point that's on a line that goes through this segment, so point D is on this line CP. D to B is congruent to D to A. Since I know that those two things are congruent, then that tells me that this is actually CP is a perpendicular bisector at a 90 degrees, and this is congruent to this. So D is on that perpendicular bisector. Concurrent. What concurrent means is when 3 or more lines, rays, or segment intersect at the same point. So if I have this, they all intersect at the same point. We have 3 or more, those are concurrent. If I have this, those are not concurrent because they don't intersect at the same point, okay? Point of concurrency is just this point where they are concurrent. We call it a point of concurrency. Okay, concurrency of perpendicular bisectors. So if we have a triangle, I can draw perpendicular bisectors on this triangle. So D to P is a perpendicular bisector. It hits at 90-degree angles. This piece is equal to this piece. E to P is a perpendicular bisector. Hits at a 90-degree angle. This piece is equal to this piece. P to F is a perpendicular bisector. Hits at a 90-degree angle. This piece is congruent to this piece. So I can have that point of concurrency. They will all three hit at the same point. That point of concurrency is right here. There's something special about that point of concurrency. And the special thing is, if I take from that point of concurrency out to the vertice, so out to A, out to B, and out to C, these lines will always be congruent to one another. Okay? This point of concurrency right here has a special name, and it is called the circumcenter. So, perpendicular bisectors, there's 3 on a triangle. They will all intersect at the same point, so we call that a point of concurrency. Since they are perpendicular bisectors, their point of concurrency, we have a special name for them. It's called the circumcenter. The special thing with the circumcenter is that if I take from the circumcenter to each of the vertices, those will all be congruent segments. So essentially what I've created here is 6 triangles within this figure. These 2 are congruent, these 2 are congruent, and these 2 are congruent. Okay? Now, circumcenter, depending on what kind of triangle it is, happens in different places. If we have an acute triangle, the circumcenter will happen somewhere inside the triangle. If we have a right triangle, it will happen on the triangle. And if we have an obtuse triangle, it will happen outside the triangle. The other cool thing, so there's a lot of information here, guys, I know. The other cool thing is if I draw a circle around a triangle, okay, so draw the circle around the triangle. The circle looks different depending on if it's acute, right, or obtuse. If I draw the circle around the triangle, you will notice that your circumcenter, or the point of concurrency of these perpendicular bisectors, is always in the center of the circle. That will always be the center of the circle, okay? Pause me and try 1, 2, and 3 on your own. When you're done, unpause me. Okay, so number 1, this is a perpendicular bisector, so this piece equals this piece, so I'm just going to do 2x equals 5x minus 6. I'm going to subtract 2x from both sides, so I get 3x, and I'm going to add 6 to both sides, so I get 6. So I get x equals 2, but they actually want me to find a to b. So a to b is 2 times 2, so ab equals 4 here. Same idea here. I'm going to do 3x plus 8 equals 7x minus 16. Subtract 3x, so I get 4x. Add 16, and I get 24. So x equals 6, but I need to plug it back in to find a to b. I'm going to do 3 times 6 is 6, 12, 18. 18 plus 8 is 26. So AB equals 26. One more. Same thing here. This piece equals this piece. So 11x minus 9 equals 6x plus 11. I'm going to subtract 6x, and I get 5x. I'm going to add 9, and I get 20. So I get x equals 4. Plug it back into a to b. So I'm going to do 11 times 4, which is 44. 44 minus 9 is 35. So AB equals 35. All right, next page. Tell whether the information in the diagram allows you to conclude that C is on a perpendicular bisector. So this one would be if I were to draw a line down, and that's not the best line, this guy is equal to this guy. Therefore, it would be on the perpendicular bisector by the converse of the theorem. This one, we know that this piece equals this piece and this piece, but we don't know if it's 90 degrees. So this would be no. This one, this piece equals this piece at a 90-degree angle. So since this equals this, then we would say yes by the converse. All right, use the diagram. EH is a perpendicular bisector of DF. Find the indicated measures. Go ahead and pause me and try 7 through 12 on your own. Okay? Unpause me when you're done. So EF, so first thing I'm going to need to do is I'm going to need to generally just find X and Y. So since this, I could extend this, this is equal to this. That means that G is on this perpendicular bisector, so this piece equals this piece, which then means that this piece equals this piece, right? So to find X, I can do 7X plus 9 equals 9X minus 1. So I'm going to subtract 7X, and I get 2X. I'm going to add 1, so I get 10. So 2X equals 10, so X equals 5. That's going to help me in finding these. I'm also going to find Y at the same time. So I'm going to set up these equal each other. So I'm going to do 10Y minus 4 equals 7Y plus 8. Subtract 7X, or 7, that should be Y, sorry. Subtract 7Y and I get 3Y. Add 4 and I get 12. So Y equals 4. And that's going to help me on finding all these. So E to F is 7X plus 9, so I'm going to plug in my 5. So 7 times 5 is 35. 35 plus 9 would be 44. D to E would have to be the same. You could plug it back in and make sure, but you don't have to. I would actually recommend on a homework assignment on the test or quiz to actually plug it back in and make sure, because 5 times 9 is 45. 45 minus 1 does give me the 44, but those two things should be equal. F to G, plug in my Y, so 7 times 4 is 28. 28 plus 8 is 36. D to G would then be 36 also. F to H, so we're going to plug in 3 times 5 is 15. I'm going to write this one down. Plus 4 times 4 is 16. If I add those, I get 31 for F to H. That means H to D is also 31. But they want me to find D to F, which is 2 of those 31, so that'd be 62. Okay. Couple more problems here. In the diagram, the perpendicular bisectors of ABC meet at point G are shown dashed. Find the indicated measure. So A to G would be this guy. Okay, A to G is going to be our hardest. I'm going to take that triangle out real quick. We know that this is 20. We know this guy will equal this guy because that's that theorem. If we have the circumcenter, then going to the vertices are all equal, right? So we're going to find this. It's a right triangle. We're finding a missing side on a right triangle. To find a missing side on a right triangle, we can do the Pythagorean theorem. So 20 squared plus x squared equals 25 squared. So that's 400 plus x squared equals 625. Subtract 400, so I get x squared equals 225, and I square root it, so AG would be 15. Oh, I was finding DG. We don't even have to find DG on here. DG equals 15. I'm sorry, guys. AG probably just confused you. AG is the same as G to C, so it is 25. B to D would be the same as A to D, so it is 20. C to F would be the same thing as A to F, so it is 24. B to G is the same as A to G and G to C, so it is 25. C to E is the same as B to E, so it is 15. And then A to C is 24 and 24, so 48. What I was going over before is good for you guys to know because you'll probably have homework and test problems on it. So you can find this third side of these triangles because these are all, remember, right triangles because that's a perpendicular bisector. So you're going to use Pythagorean theorem and a squared plus b squared equals c squared. Okay, number 19. I know that this guy equals this guy and I know that this guy equals this guy. So to find this, you know, 2x minus 7 equals 2y plus 1. And we also know that 4y minus 6 equals 3x minus 10, right? So what I'm going to do is I'm going to get my x or my y by itself on one of these. Okay, so what I'm going to do is I'm going to get this in the form where I have my x and my y's on one side and my numbers on the other. So I'm going to subtract 2y, so I have 2x minus 2y equals, I'm going to add 7, and I get 8. I'm going to do the same thing over here. I'm going to subtract 3x, so I get negative 3x plus 4y. I'm going to add 6 to this side equals negative 4. Now this goes all the way back to Algebra 1, where we have this system of linear equations, and I'm going to use elimination. I'm going to multiply this whole guy by 2. So I have 4x minus 4y equals 16. I'm going to bring this guy back over. Negative 3x plus 4y equals negative 4. I do that because my y's then cancel. Okay? And so now I add, going straight down, this gives me x equals 16 minus 4 is 12. So x equals 12. Once I found x, I can then find y by plugging it back into one of these two equations. I'm going to go to the top. So 2 times 12 is 24. Minus 2y equals 8. Subtract 24 from both sides, I get negative 2y equals 8 minus 24 is negative 16. Divide by negative 2, divide by negative 2, I get y equals 8. Now, they could have asked me to plug it back in and find the distances, but they're just asking for x and y on those. Homework. So, supplemental packet. Your next Schoology assignment is asking for you to complete the very first page in the supplemental packet. So you're going to complete this page. It is called Using Perpendicular Bisectors. And you're also going to complete the back of it. Okay? And you're going to enter your answers into that Schoology assignment from that page. Okay? All right. Thanks, guys.